Welcome back to ch205. Today I'll be talking about solving for the root of a function using Newton's method. So in Newton's method we have to start with the guess value. Let's say that is v, and using this guess value we're going to construct another variable called b, which is equal to v minus f of v divided by f prime of v, where f prime is the derivative of f. So f is given, we have to calculate f prime, we have to form the right hand side, and then we equate the right hand side to b as another variable. Alright, in step 3 we're going to replace our old value of v by the new variable calculated b. Okay, so after we replace v by b, we iterate from step 2. We iterate over b and replacing v by b until f of v becomes almost 0 or close to 0. So here's an example. Let's say we want to find the root of f of v, which is the equation of state. Everything moved to the left side. We want to set this to 0 and then find for v such that it satisfies this equality. Everything else other than v is constant. P is the pressure's constant, A, B are constant. By the way, this A and this B is different from this B. So hopefully this is not confusing. This B is a constant for the van der Waals equation. This B is the variable we just introduced. So anyways, so if this is f of v, we're going to calculate f prime of v. F prime of v is, we look at f of v and you see that there are two terms here. So we're going to use the multiplication rule, in which we calculate the derivative of the first term times the second, and then plus derivative of the second term times the first. Okay, so the derivative of the first term is minus 2a over v cubed. So that's the derivative of this term. If you forgot how to calculate this, I highly recommend going back to maybe high school calculus and see how we can find the derivative of 1 over v squared. A is a constant, so it doesn't have any derivative. It actually comes out of the derivative or differentiation as a constant term. It's not applied when we get the derivative of this whole term. Alright, so that's the derivative of this term times v minus b, and then plus derivative of this term, which is 1, right? Derivative of v is 1, times the second is p plus a over v cubed. And then derivative of the last term is 0 because both of them are constant and independent of v. Alright, so now we have f of v, we have f prime of v. We can go and calculate, we can solve for the root using a spreadsheet. So to do that, we're going to form 4 columns, v, f of v, f prime of v, and b. So let's start with a guess point. If you recall from video 1, we plotted a function, we found the root is somewhere between 4 and 5. So I want to put the guess point as like 4 because it's, I think, closer to the root. So here's 4, f of v. We have to implement the left-hand side of this equality. We have to implement the left-hand side on this cell, which is exactly like the one is written. So this is P, that's the blue cell, plus A, that's the black or maybe green cell right here, over V cubed, sorry, V squared, so this is V, purple cell, V squared, and then times V minus B, that is B, the brown cell, and then everything minus R, which is the green cell up here, times T, which is the orange cell. Okay, so this is the left-hand side of this equality, which we call f of v, right? Okay, I'm going to hit enter. How about f prime of v? Then we have to implement f prime of v right here, which I did already. So I don't think there's any point to this equation, so I just hit enter. And then b is equal to v minus fv over f prime of v. So let's look at how we can calculate b. So the first term is v, which is a9, this blue cell, minus f of v, which is the green cell, divided by f prime of v, which is the purple cell. So that's exactly v minus f of v over f prime of v. I'm going to hit enter. All right. So what's next? I have to iterate. Well, first I have to replace v by b. So this is our next v, and should be replaced by b. So I would say this is equal to the b we just calculated. So this is equal to d9, right? So this is cell d9, right? Hit enter. All right, so now I have my new v. I updated, so initially it was 4. Now I'm having a better guess, which is 4.23. Then highlight the equations for these three, or I highlight these three cells and then drag one row down. All right, now I have everything set properly. So next, we have to iterate over step 2 and 3. So that means then I have to replace v by b again, and then highlight these three and drag one level down and so forth, and iterate over that step. So that means I'm going to highlight these 4 and then drag everything all the way down until I see f of v equal to 0. There you go. In fact, in the third step, this is third step, you get f of v equal to 0, and this is the root. If you go further down, your root doesn't change. That means you're doing unnecessary steps. So this is the step. This is the step you have to stop. Okay. So the root is going to be 4.22998 up to 5 digits. All right. So that was Newton's method. I hope this is clear how we can solve for the root of a function using Newton's method. In such problems, what is normally given is the function, and we have to calculate derivative ourselves. So derivative is not given to us. So make sure you refresh your calculus from high school and be able to calculate the derivative of almost any function. All right, so stay tuned and see you in the next section.